Guys, we're going to go over mathematical induction today. So this will be kind of an introduction to mathematical induction. For number two on the worksheet, I did email you a tutorial just because that problem has fractions. It's going to be a little bit longer, but the three steps of mathematical induction are the same nonetheless. So we always start off by checking if the statement is true, because if the statement is false, you don't have to continue with the other two steps. So starting with checking if the statement is true, I'm going to replace the n with just 1. So given the example below, I'm going to replace the n in 2n minus 1 with just 1 for n, and equals n squared. I'm going to write 1 squared. So here I have 2 times 1, which is 2, minus 1, which gives me 1, equals 1 squared, which is also just 1. So since this statement is true, I'm going to proceed with the other two steps. Starting off, I'm going to replace the n's with k. So I'm going to write 1 plus 3 plus 5 plus 7, same thing as the sequence above, plus, instead of 2n minus 1, I'll write 2k minus 1 equals k squared. Now, the point of this is because now I know the value of this sequence. I know that 1 plus 3 plus 5 plus 7 plus 2k minus 1 is equal to k squared. So that's just something to keep in mind when we go to the third step, which is to replace n with k plus 1. Please note that I put k plus 1 in parentheses because anytime you substitute anything with a plus or minus sign, meaning an expression, it should be in parentheses. So anything that needs to be distributed is so done correctly. So writing this out for k plus 1, 1 plus 3 plus 5 plus 7, I want to note on the left-hand side of the equal sign, which I am working on right now, I'm going to bring everything down and I am going to add the k plus 1 now. So meaning instead of 2k minus 1, I'm going to write 2. I'm going to replace the k with k plus 1 and I'm going to write minus 1. So I've just rewritten this 2k minus 1 by replacing the k with k plus 1, but I added it on. The reason I'm stating that is because you add it on the left-hand side of the equal sign. But on the right-hand side of the equal sign, you're just going to substitute it. So meaning you're just going to replace this k with k plus 1 in parentheses, of course, because when I bring down the square, I want to make sure I square all of it. Now, why do I only add it onto the left but substitute it onto the right? This goes back to why n equals k is done, meaning the one in orange. Because right now, if I look here, 1 plus 3 plus 5 plus 7 plus 2k minus 1, I know this value. I got it up here. 1 plus 3 plus 5 plus 7 plus 2k minus 1 does equal to k squared. So I'm going to replace this entire part right here with k squared. Everything else in yellow, I'm just going to bring down business as usual. So now comes the algebra part. Now, from n equals to 1, which was in blue, this statement is true. So that means when I'm done simplifying this statement should be true. One side of the equal sign should equal to the other. So I'm going to work out the left side first. So k squared plus, I'm going to distribute this 2 because my k plus 1 was put in parentheses correctly, so I can distribute correctly, giving me 2k plus 2, bring down the minus 1 you haven't used. And then what I have here is k squared plus 2k, and then 2 minus 1 will give me plus 1. Now I'm going to work on the right side. K plus 1 squared means k plus 1 times k plus 1. And if I FOIL this, sidebar, it will give me k squared, plus k plus k plus 1. So I'm going to bring down the k squared. K plus k gives me 2k plus 1. So I'm going to bring that back down here. So k squared plus 2k plus 1. Left side does equal to the right. It's proven that it's true. I hope this helps, guys.